Hello friends, this is lesson 20, and lesson 20 again we are going to talk about supervised machine learning, a new type which is called KNN, and KNN stands for K nearest neighbors, and it is, from here you can understand, it is a supervised machine learning. So then we will talk about the K value, what do you mean by K here, then the metrics here, and then we will give some examples for them. Let's start with the first topic. So here KNN, abbreviation form of K nearest neighbors. So what is that? K nearest neighbor or neighbors is one of the simplest predictive supervised model. So here we have 2 points. One is simplest predictive model and another one is called the supervised model. So simplest, why it is called simplest? Because it does not require much mathematical assumptions. That is why it is called simple predictive model. And it is called supervised model, so it means it predicts only discrete response values. Discrete response values, it means true and false, yes and no, like that. So that will be the output for the model. So here this one is important, friends. It classifies a new data point based on how its neighbors are classified. This is the logic behind KNN. So the KNN classifies a new data point based on its neighbors. How the neighbors are classified, so the new data point also will be classified based on that. Let me give you a real life examples. For example, if your friends are taking decision about you whether you are a good boy or a bad boy, so they will look at your friends. They will see how many good friends you have and how many bad friends you have. So if all of your friends are good, so they will consider, yeah, you are also a good boy. If some of them are bad, then they will count how many goods are there and how many bads are there. If the number of goods are more, then again they will say, yeah, he is still a good boy. If the number of bad friends are more, then they will take decision, you are also a bad guy. So what it does, it classifies a new data point based on how the neighbors are classified. So here, how to identify the nearest neighbors? So the nearest neighbors, that will be calculated through a simple formula which is called Euclidean distance measurement, or through this formula Euclidean distance we can calculate the nearest neighbors, the distance for that. That is why it is called simplest predictive model. It does not require much statistics or probabilities, only a single formula and simple formula is there, and this formula is equal to square root of x1 minus y1 whole square plus x2 minus y2 whole square. Then we are taking the square root for that, and that is measuring the distance between the neighbors, and then we can easily find the nearest neighbors. Then the model predicts how many true values are there and how many false values are there. If the number of true values are more than the number of false values, so the new data points is also belonging to the true values. So here, what is K here in KNN? So K in KNN is an integer parameter or value which is greater than 1. So it should be selected greater than 1, and it is better to be selected as an odd number, because if even numbers are there, so it is difficult. The model also cannot identify, because too bad and too good, we cannot say whether the new data point is good or bad. So it should be 5 or it should be 3, then we can say how many good are there and how many bads are there. Then it very easily we can take the decision. So it should be greater than 1, an odd number that refers to the number of nearest neighbors to include in majority of voting process. This you have to understand, it is simple. And then the metrics here, since it is a classification model, then we have to calculate the classification accuracy. It means the confusion matrix. Then we have to calculate the types of error, like if you are using confusion matrix there, true values, positive through positive, through positive through negative, false positive and false negative, those values, and through that we can calculate the sensitivity of the model, precision of the model, like that, accuracy of the model. We have, since it is a classification model, so we can calculate those metrics also. But for calculating and finding the nearest neighbors, this is the formula which is called Euclidean distance. Through this we can calculate and measure the nearest neighbors, the distance for nearest neighbors. So let's see here. So we talked about k nearest neighbor, and we said it is a simplest predictive supervised model and does not require much mathematical assumptions, and we said it is classifying the data points based on nearest neighbors. So k, we talked about k value, it is greater than 1, it should be odd number, and it is nothing but the nearest neighbors which are included there for voting process. So here is an example, and through this example you can easily understand the KN inference. So here we have two samples. For example, this is red colors and then we have green colors, and here I have a new data point. So the new data point, we are confused, or the model is confused whether this new data point is belonging to this group or to the green group. So we are selecting the k number, so we say k is equal to 3. How many nearest neighbors we are selecting? 3 nearest neighbors. If you are circling 3 nearest neighbors, so in that we have 2 red neighbors and we have only 1 green neighbor. So the model easily predicts this new data point belongs to the red neighbors, because here the majority we have 2 red and only 1 green. So the new data point belongs to red, and that is converted to red. Another very good example here we have, friends. Here we have person weight and person height is here, and default values are given for them. Some of them are underweight and some of them are normal. Now the question is whether this new data point falls under normal or under the underweight. That we have to calculate, and for that we have to calculate the distance and find the nearest neighbors. Through the nearest neighbors we can easily, or the model can easily identify whether this one falls under normal or under the underweight. So this is the formula. You apply the formula and check how we can calculate. So all the weight values are listed here, and all the height values are listed here, and I created another list for normal and underweight. So according to that we have to put the values. Underweight is the first value, normal, underweight. So all the values are listed here. We have 3 lists. So later that we have to calculate the distance. So d is equal to the square root of x1 minus y1. So what is x1? x1 is this value, this is x1 minus weight. So the weight, what we have to do, we have to consider all the values, not a single value, all the values. So that is why I am creating a for loop here towards to each and every value here. 51, it means 57 minus 51, 57 minus 62, like that it is calculating for all. In the same way here for the height, we have to give this value 172 minus the height, the whole range, and we have to square them according to the formula, because it is square here, square and square. Here I have squared this one and I have squared this, and that is calculated and stored in D. And then I have converted it to the data frame. So here we have weight and the values for the dictionary here for this one. This one is the key and this one is the value, if you remember, in dictionary. Otherwise you have to refer the previous lectures for better understanding. So here this list is selected for the first key, this is the second key, and this is the value which is coming from this list, and here we have default values, the third one, and then we have the distance which is calculated here, and that values are all coming under the distance. So it is converted to data frame, and I have printed the data frame here. Now let's see. Yeah, the data frame, the data frame is printed here, and the calculated distance is also here under the distance column. So now we have to take the decision here. Now if k value is equal to how much? 1. So if k value is equal to 1, it means the last value is the nearest neighbor to this value. So what is the last value? It is normal. So we can easily say this value is also normal, or the new data point, or this data point is also normal. The label for that is normal. But if we take not 2, 3 we are taking, it should be odd number. So it is 3. Now if k is equal to 3, we have to consider 3 friends or 3 values from this list. Which 3 values? So we have to arrange the values in ascending order or descending order. So we have to start from the smallest value and go up to the largest value, and for that let me put the values here. So what is the smallest value first? The smallest value is this one, I think. Yeah, this one is the smallest, the first smallest value. I am putting it here. So what is the label for this? The label is underweight. So this one is underweight. What is the second smallest? The second smallest is this one. So I put it here. Yeah, this is, but this one is not underweight, it is normal. So let's see the third one. Yeah, the third one is this one, friends. Third smallest value. So here it is also normal. So how many normals are there? 2 normals we have, and only 1 underweight. What is in the result? So we said we have to count the nearest neighbors. So 2 nearest neighbors are normal and 1 is underweight. So we can take decision this value or the new data point falls under the normal label. If you are changing this one to 5, it is very simple, 5. So again you have to take 5 values. So what is the third, the fourth smallest value? The fourth smallest value, maybe this one, yeah. Yeah, I am putting it here. So it is also under, this one is underweight. So what is the next value for that? I think this one is the next value, 7.7, this one. Yeah. Let me see, this is 1.2, this one. This is the smallest, I think. So yeah, these are both the same. So we take one of them. So now this one is also normal. How many normals we have? 3 normals, and we have 2 underweight. Then again we can say this new data point falls under the normal label. So like that you have to calculate. You have to be very keen here, otherwise you have to sort the numbers, then you can easily identify whether it is normal or underweight. So now let's see here, classification of species and iris data set. We talked about iris data set in previous lectures, you have to refer that. So it is a standard data set, and it has it is talking about the flowers, different types of flowers, and they are classified based on their sepal length and sepal weight and petal length and petal weight. So these are nothing but the features, and this is called the output or response value. So it is nothing but discrete value. So how many rows are there? 150 rows. And how many columns? We have 5 columns. And since the labels here, the output labels are in the form of qualitative value, this should be converted to numbers, because the model needs quantitative values, not qualitative values. So I am using dummy variables here, mapping them. So I say, okay, the first value, which is called iris setosa. So setosa is assigned 0, versicolor is assigned 1, and virginica is assigned 2, and they are mapped. And now let's see here. Yeah, I'm printing it here. Yeah, they are changed to from text to numbers. Now the model can easily predict whether it is 0, 1 or 2. If it is 0, it means setosa. If it is 1, it means it is versicolor. If the model is predicting 2, so it means it is virginica. Now let's see here. Again, I am using scikit-learn, friends. From scikit-learn's neighbors, and then I am importing this one, k neighbors classifier. And we have to split the data into training and testing. So I am using scikit-learn, again model selection, and from here I am calling this function or importing this functions. So these are our features. 4 features we have: sepal length, sepal weight, petal length and petal weight, and it is in the form of data frame. What is response value? This is response value. Y value, response value, species. So it is nothing but a NumPy array or a series. This one is data frame and this one is a series or NumPy array. Now the data is split into training and testing values here, and testing size is taken 0.2. It means 20% of the data is going for testing and 80% of that will be for training, and randomly they are selected here. So I created the model and I say the number of neighbors equal to 3. You can take the decision how many neighbors you want. So based on that, the number of neighbors, you can understand how many. So here we discuss what do you mean by neighbors: 3 neighbors, 4 neighbors, 5 neighbors. From here you can easily understand, you have to refer this. So then I fed the model the data, then we are predicting the values here. Yeah, the model is created. And now before we are going to talk about the other things, see here the number of neighbors is equal to 3. We can change the number of neighbors to 1, to 3, to 5, to like that, different values we can give. And for that I created a for loop here, and the number of k changes from 1 to 15. And for that, here I am calculating the accuracy of the model, and we will check whether the accuracy is increasing or decreasing just by increasing the number of neighbors here or decreasing the number of neighbors. We will see here. So if the number of neighbor is equal to 1, the accuracy is 100%, 2 is also 100%, 3 also 100%, like that it goes up to 15. And the number of accuracies, the accuracies are printed here, but here the accuracy decreases. It is 96%, or we can say 97%, and again it is increased here, and we can take the mean of or the average of these values. So the mean will be 98%. So you can change and you can take the decision how many neighbors you want from here. If you want, okay, 3 neighbors, you just put 3, then for 3 it will be showing you the accuracy, and for 5, for 7, like that, you have to take the decision how many neighbors you want for the model. So now let's go for predictions. Now here is the value. How many values I have provided? 4 values, because the model requires 4 features. These are the 4 features: length of the sepal, weight of the sepal, petal length and petal weight. 4 values if you provide, so the model will predict the value for us. So the model predicts 1. 1 means what? It is nothing but here it says the color, the flower is versicolor. If we change the petal length, for example, to 5, and now let's see, it is predicting another flower which is 2, and you see the 2 is given to virginica. And you can change these values and the model will predict you different labels, and you can understand which is which label is which flower. So here then we are talking about classification metrics, since KNN is also a classification model. So here we have to calculate the model accuracy, confusion matrix, and then if you want to print the summary for all, then we will call this function classification report, then it will give us the summary for all. So here I have printed only the accuracy. So the accuracy is 97%, the whole model accuracy is 97%, and then I am going to check here the actual values versus the predicted values. So these are nothing but the actual values. So the actual values x, I am printing x test, a for loop I am creating here, the for loop, and it is iterating from 1 to how much y test, the size of that. So again this is the predicted values here. So let's see here, these are the actual values and these are the predicted values. When the actual value was 0, the predicted value is also 0. When it is 1, the predicted value is also 1. But here we have one error. It means there is some misclassification. Maybe we have to check it. Where is that? Okay, let me find it here. Yeah, it is here. The actual value is 1, but the predicted value is 2. That is why it is showing us the difference here. I have printed the difference between actual values and predicted values, and it is showing me 1. It means only one misclassification is there. That is why the accuracy is decreased to 96%. Okay friends, now let's see here the confusion matrix. So this is the confusion matrix for the KNN model for this example, and let us see here the classification report, and this is the classification report, this is the accuracy, and here also we can see the accuracy. And here 3 labels we have. Label 1 means Setosa, and this one is versicolor, Virginica, and these are the precision 100%, 100%, 86% for this. Recall is also 100%, 92% in this one. So these are the number of observations. We talked about F score. It is nothing but the average of these two. It means 2 into precision into recall divided by the sum of these two numbers. So that is giving you this F score. So then we have macro average. The macro average is nothing but the average of these 3 values, like we have for first label, second label, and third label. Add all these numbers and divide it by 3, it is giving you this one. But if we go for weighted average, so the weighted average is something different. First you have to multiply this one into the number of observations, the second one into the number of observations, the third one into the number of observations. So you find the sum and divide it by total number of observations. That is giving you this percentage, 97%. The same you have to calculate for others also. So this is all about KNN. I hope you understood. We give an example here. So through this example, very simple example, you can understand easily the logic of KNN. And here you have to see this example, and we talked about, okay, KNN, we said it is a supervised machine learning model, and it is simplest because it does not require much mathematical assumptions, and it is classifying the data points based on the nearest neighbors, how many nearest neighbors are there. Then we talked about K value, and we talked about the metrics. I hope you understood this much about the KNN.